All right, as we continue our journey with rational expressions, we're now going to look at section 6.3, which is multiplying and dividing rational expressions. And to be honest, multiplying and dividing rational expressions are fairly straightforward as long as you know how to factor. And actually, I feel it kind of calming and relaxing as a stress relief because things cancel, and that kind of makes me, I like to do like check-off lists, and when you check things off, it makes you feel relaxed, and you got to do a lot of crossing off and checking with these. So, multiplying expressions, first thing you want to do is just like all the other ones is you want to factor the numerator and the denominator. After that, you want to cancel any like factors. And when you cancel like factors, you want to look top slash bottom and diagonally. Okay, you look at top and bottom to any like factors and also diagonally for any like factors. Once every like factor is canceled, just like any type of multiplying fractions, you multiply straight across. And just like we talked about last section, we then state any restrictions for the variable. Remember, the denominator can never equal 0. All right, so we have a couple examples here. All right, so remember these are in parentheses here because so those are all each factors. And so the first thing we want to look to do is factor. These are factored already. Can't factor them any further. Then I cancel like factors. Look top, bottom, or diagonally. So top, bottom, these are not like factors. Top, bottom, these are not like factors. But diagonally, I have an x plus 3 and an x plus 3. That's what I'm saying. Kind of stress relief because it cancels out and makes it something a little trickier, much simpler. Diagonally this way does not cancel. So now I multiply straight across. Just remember when things cancel, they cancel at 1. So when I multiply straight across, I'm doing 1 times x minus 5, which is just x minus 5. And then x plus 4 times 1, which is x plus 4. So that would be our final answer. We do need to restrict the variable. So I'm going to say x plus 4 equals 0, x plus 3 equals 0. Again, those are my denominator factors. So I'm saying x cannot equal negative 4, and then x cannot equal negative 3. All right, as we go to example 2, first thing I'm going to do is factor. And so I do have some things I can factor here. This would be difference of squares. A squared is a perfect square. They're being subtracted, and so is 1. So I would take the square root of a squared, which is a. Square root of 1 is 1. So I have plus minus. So a plus 1, a minus 1. And that's a to the 4th times 2 times a. So I'm just going to write it as 2 times a to kind of remind you that that's factored there. And then times a plus 1. So now as I look to cancel top, bottom, or diagonally, I have an a plus 1 and an a plus 1. Top, bottom, I don't have anything, but diagonally this way, I have an a and an a to the 4th. So remember, that means there's like one a up top, but then a times itself 4 times on the bottom. So I'm going to get this a to cancel with one of the a's down here. So I'm going to be left with a to the 3rd now after that a on the top cancels. So I am left with now 2, as I multiply straight across, 2 times a minus 1, and I'm not going to distribute that. I'm just going to leave it in factored form. We're always going to leave everything factored here. And then the only thing left on the denominator is a to the 3rd. All right, and then I can say a cannot equal anything that was ever in the denominator. So if I said a to the 4th equal to 0, that would be a cannot equal 0. So a cannot equal 0. And then a plus 1, if I set that equal to 0, I get a cannot equal negative 1. All right, for number 3, I have a lot of factoring here. So I'd have x squared plus 6x. So there is a GCF of x. On the bottom, I have x plus 6 times x plus 6. So even though I'm not necessarily factoring it, I'm going to rewrite it to make it look more factored. So remember, x plus 6 quantity squared means x plus 6 times itself. So x plus 6 times x plus 6. I'm going to factor the top here with Sam. So what multiplies to 6 and adds to 1 would be x plus 6, x plus 1. And then on the bottom, I have difference of squares. So again, square root of x squared is x, square root of 1 is 1, and then we always have opposite signs. So we factored a lot there, but now's the stress relief because we can look to cancel. And I think a lot of things are going to cancel for this one. So top, bottom, ooh, x plus 6, x plus 6, ooh, things just got checked off the bucket list. All right, diagonally this way, x plus 6, x plus 6, all right. And then top, bottom here, x plus 1, x plus 1. And lo and behold, we made this complicated problem left to only an x on the top and an x minus 1 on the bottom. Feels kind of stress relief. Something simple, something complex turned into something much simpler. All right, then I state my restrictions. So x plus 6, if I set that equal to 0, x can equal negative 6. That's the same factor, so I don't have to do it again. If I set x plus 1 equal to 0, I would say x cannot equal negative 1. If I said x minus 1 equals 0, x cannot equal positive 1. All right, I want you to try those 3 on your own. Remember to factor first. For the back, now we're going to be dividing rational expressions. You're going to change the division to multiplication, just like we divided fractions before. And you take the reciprocal of the second fraction. You're then going to follow the multiplication steps. And remember, the main difference here is you're going to restrict the factors of both the numerator and denominator of the second fraction. So normally, you just restrict the denominator, but since we are flipping that second fraction, the numerator of the second fraction ultimately comes the denominator once you flip it. So you have to restrict top and bottom of both the second fraction. All right, so as we look at our examples here, first thing, we're changing the division to multiplication. So I'm leaving the first fraction alone. I change that division to multiplication, flip my fraction. So that was step 1. Now we're following the multiplication steps. Our multiplication steps say to factor. So I have a lot of Sam factoring here. X times x. What multiplies to negative 5 adds to negative 4. It's 5 and 1 minus 5 positive 1. And then what multiplies to 5 and adds to negative 4. So we would now have, oh, that's a 4. I don't just copy that over wrong. What multiplies to 4 and adds to negative 4 would be negative 2, negative 2. All right, we continue our factoring. What multiplies to negative 12 and adds to 4? So that'd be 6 and 2, positive 6, negative 2. And then last, what multiplies to 15, negative 15 and adds to negative 2, would be 5 and 3, negative 5, positive 3. And so now we can do our canceling, the stress relief. So again, I look, top, bottom, I have x minus 2, x minus 2, x minus 5, x minus 5. And that would be it. So when I go to multiply, again, multiply straight across. So I'd have x plus 1 times x plus 6. And on my bottom, x minus 2 and x plus 3. Do not multiply these out. Just leave them factored. Don't make it harder for yourself. And then I state my restriction. So my denominator here, if I said x minus 2 equals 0, I get x cannot equal 2. That's the same factor, so I don't have to write it again. Now, again, if you look here, this x plus 6 times x minus 2 was really ultimately in the denominator to start. So I have to restrict every factor in my second fraction. So I would say negative x cannot equal negative 6, because negative 6 plus 6 is 0. 2 minus 2 is 0, so I already have the 2. If I said x minus 5 equal to 0, I would get positive 5. 5 minus 5 is 0. And then I also said that factor equals 0. X plus 3 equals 0 is x cannot equal negative 3. So again, the main difference, after your first step, just change the division to multiplication, follow your multiplication, but you have to restrict every factor of that second fraction. All right, one more example. You might see a fraction written this way. And if you do, not a big deal. Remember, this line means division. So what I'm going to do is I'm going to leave that top fraction alone. I'm going to change the division to multiplication, but then I'm going to flip this fraction. So I have x minus 5 and 4x squared minus 1. And so now I factor. I can't factor the top at all. I can factor the bottom here with difference of squares. X plus 5 and x minus 5. This stays as x minus 5. And then my bottom here is difference of squares. 4 is a perfect square, so is x squared, and so is 1. So I'm going to have it as 2x plus 1, 2x minus 1. And now I'm going to cancel my like factors, either top, bottom, or diagonally. So I have a 2x plus 1, 2x plus 1, x minus 5, x minus 5. And so remember, we're left with 1 anytime we cancel. So as I multiply straight across, I'm really multiplying 1 times 1. So I have 1 on the top, and then x plus 5, and 2x minus 1 on the bottom. As I go to set my denominators, factors equal to 0. If I said x plus 5 equal to 0, that would be negative 5. So x cannot equal negative 5. Negative 5 plus 5 is 0. If I said x minus 5 equal to 0, that would be positive 5. 5 minus 5 is 0. And just remember, you have to set every factor of the second fraction equal to 0. So I already set this one equal to 0, because that canceled. If I set 2x plus 1 equal to 0, 2x plus 1 equals 0, I would subtract 1, and then divide by 2. So x cannot equal negative 1/2. And then the same thing here, but that would be positive 1/2. All right, and that's division. Try those 3 examples.